So good afternoon, everyone. So today we are going to cover the second aspect of solar energy. If you remember in the first lecture of solar energy, we covered about solar thermal routes. Okay. Now second is the solar photovoltaic routes. So in the solar thermal route, we have discussed enough about the solar collectors, how the solar collector is being designed accordingly to get the maximum output in terms of consumption of heat energy so that it can be converted to electrical energy. Okay, so in the second aspect, the solar photovoltaic route, that is again most common, most predominantly used in this particular all the countries. That is, here you are talking about direct conversion of solar energy to electrical energy. Okay, so there are pros and cons, no doubt, in the system also. But when you are thinking about a clean fuels, when you're thinking about a fuel without any environmental pollution generation, you will leave aside certain cons. You will leave aside certain drawbacks. And there's a major advantage you always going to harness from the renewable sources of energy. So we're going to discuss something in detail about this topic, that is solar photovoltaic routes, and you know very well about certain things. I'm not going to touch all those kind of things. Okay, so solar photovoltaic or solar cell is a device. Basically, it's made up of a particular semiconductor, or this semiconductor, generally that is being used, or what that was most commonly used was silicon. Now you have a different kind of semiconductor materials depending on applications. Now, how it is executing the things I want to discuss in detail now. So it can be but that is a sure thing. You need a semiconductor. Why you need a semiconductor? I'm going to discuss with you. It can be silicon, it can be gallium arsenide, cadmium, telluride. So these all are the category of semiconductors that convert sunlight directly into electricity. How? I'm going to discuss. Okay, it's written over here, but I'm going to explain these things. Okay, now why I'm saying, when you're talking about solar photovoltaic cells or solar photovoltaic routes or solar cells, it's always made of semiconductor. So it is like, this is a semiconductor, beta. So it is NP type, but generally I'm quoting it some other way. Okay, this is a semiconductor. There is a valence band, there's a conduction band. Between valence band and conduction band, there is a energy gap. This is called Eg. Okay, so in all the semiconductors, you have two things: valence band and conduction band. And these valence band and conduction band are being separated by the energy gap, Eg. Band gap, that's called band gap. So it can vary depending upon semiconductor. It can be 1.8 electron volt, it can be 2 electron volt, it can be 3 electron volt, it can be 2.8 electron volt, depending upon which type of pure semiconductor you're going to use, or impure, or doped, or fabricated. Now, what actually is happening here, when the sunlight is falling on the semiconductors, sunlight means it's a packet of energy. It's a photons. So generally it's called photons. Okay. So what is actually happening, beta? What is actually happening when a light or suitable intensity falls on the semiconductor, electron from the valence band get excited. When it gets excited, it jumps to the conduction band, thus creating a free hole and free electron in valence and conduction band respectively. Okay, I'm trying to explain once again. Now you are using a semiconductor in all type of solar cells, for solar photovoltaic cells. Okay, so in solar photovoltaic or solar cells, you have a semiconductor. The semiconductor of different materials are there, but generally the main thing is they are made of valence band and conduction band. These valence band and conduction band is being separated by a suitable energy gap that is called band gap, Eg. Okay. Now, when sunlight falls ऑन द सेमीकंडक्टर, जो आप देखते हो, है ना, जो आगे दिखाने वाला हूं आपको मैं, जो जनरली देखते हुए फीड में लगे होते हैं. So basically, a photon of energy falls on the panel, basically. Then photon energy falls from sunlight to this particular photovoltaic cell. Electron from the valence band jumps to the conduction band by exciting itself. Excite कैसे होगा? पढ़ा हुआ आपने बेटा, +2 में सब पढ़ा हुआ बेटा कि क्या होता है. इलेक्ट्रॉन जैसे एनर्जी गेन करेगा तो ये एक्साइटेड फॉर्म में आ जाएगा. एक्साइटेड फॉर्म होगी कंडक्शन बैंड में शिफ्ट कर जाएगा ये. तो कंडक्शन में शिफ्ट हो जाएगा तो कंडक्शन बैंड में फ्री इलेक्ट्रॉन आ गए और यहाँ पे होल आ गए. होल इज पॉजिटिव चार्ज, इलेक्ट्रॉन इज नेगेटिव चार्ज. नाउ व्हाट हैपेंस, अब यहाँ पे हमने सर्किट बना रखा है. तो फ्री इलेक्ट्रॉन जैसे ही बनेगा कंडक्शन बैंड में, व्हेनेवर एज सून एज अ इलेक्ट्रॉन इज देयर इन द कंडक्शन बैंड, दिस इलेक्ट्रॉन इज बीइंग कैप्चर्ड बाय द सर्किट. यहाँ पे सर्किट में ड्रॉ कर लेते हैं, ड्रॉ कर लेते हैं. ठीक है, ड्रॉइंग मींस इंप्लीमेंट करेंगे इसको. ठीक है, तो moment you have a circuit, the free electrons are being taken up by circuit and the electrons start flowing like this. And you know very well from the definition, the flow of electron is nothing but called current. And वही हम प्रोड्यूस करना चाह रहे हैं, इसमें बेटा करंट प्रोड्यूस करना चाह रहे हैं, है ना. तो आपके कोई भी डाउट है, क्लास जैसे फिनिश होगी उसके 5 मिनट या 10 मिनट पहले, जो भी टाइम बचेगा हमारे पास, यू कैन राइट डाउन योर डाउट्स एंड यू कैन रियली आस्क. ओके, सो दिस इज समथिंग आई एम टॉकिंग अबाउट. अगर मैंने सब कुछ बताया आपको, देखो जरा बताया ना बेटा, अभी एन टाइप पी टाइप आपके होते हैं, पी टाइप एन टाइप. बेसिकली उसको हम बैलेंस और कंडक्शन बोल सकते हैं. लाइट सोर्स, फोटॉन्स आ रहे हैं, फॉल्स, देन सी द यहाँ पे इलेक्ट्रॉन जंप करेगा. ये बैंड गैप है बेटा, ये पी एन जंक्शन जो बैंड गैप है आपका, ये वाला जंप करेगा तो यहाँ पे फ्री इलेक्ट्रॉन हो गया, यहाँ पे होल हो गया. तो आपका सर्किट आ गया ना बेटा, नेगेटिव टू पॉजिटिव. फ्री इलेक्ट्रॉन कैप्चर हो जाएंगे, यहाँ पे आपका सर्किट है, फ्रंट इलेक्ट्रोड बैक इलेक्ट्रोड, यहाँ पे हो गया. फ्री इलेक्ट्रॉन जो है इलेक्ट्रॉन फ्लो मूवमेंट कर देगा फ्रॉम नेगेटिव टू पॉजिटिव. Circuit is completed and the flow of electron as per definition is always called current. And this is how a particular solar cell for solar photovoltaic cell works. Now बाकी चीजें हैं जो मैं आपको पढ़ा दूंगा. मेन एक्सपेक्ट कहाँ पे है इसमें, मेन एप्लीकेशंस कहाँ पे है, वो मेरे से थोड़ी जरूरी है, जो वहां पे रिसर्च हो रही है आज बेटा. रिसर्च यहाँ पे हो रही है बेटे कि ये आपका सेमीकंडक्टर है, ये आपका बैंड गैप है बीच में. So we are now working on a suitable type of semiconductor so that this band gap can be reduced. So what scientists are doing, scientists are trying to reduce the band gap. Why they are reducing a band gap, want to reduce the band gap, जितना band gap कम से कम होगा उतने इलेक्ट्रॉन जंप करेंगे वैलेंस टू कंडक्शन बैंड. क्यों? पहले वाले केस में जो मैंने अभी बताया है, सुटेबल इंटेंसिटी की लाइट पड़ेगी तभी आपका इलेक्ट्रॉन जंप करेगा कंडक्शन बैंड में, और जो इलेक्ट्रॉन कंडक्शन बैंड में आएगा दैट इलेक्ट्रॉन कैन बी कैप्चर्ड ओनली. So it might be possible that some electron get excited to this place and get backs until or unless they reaches to the conduction band. But if we can reduce this band gap by suitably adding certain dopants or impurities, the band gap can be reduced. If the band gap can be reduced, then more and more electrons which otherwise could have not been jumped to the conduction band, they are jumping, they are crossing it over. So this means more electrons are jumping. More electrons are jumping means more flow of electron. More flow of electron means more current. More current means more output. So that's why a lot of research in this area is going on throughout the world. Why? Because there's always a one drawback which I will be discussing later on. In solar, particular photovoltaics, huge area requirement is there. Why huge area requirement is there? Because the solar panels are not having a sufficient efficiency to convert sunlight energy to the electrical energy. They have at max efficiency of 30%, not more than that, 35 maximum suppose. And the area requirement is very high. That's why if you have seen that, you must have seen that A lot of solar panels are being installed on the top, rooftop, grounds, huge areas covered. Why huge areas covered? Because per unit area, conversion of light energy to the electrical energy is very low in case of solar photovoltaic. So for getting a good output, required amount of kilowatt hour of energy to get from the this particular system, you need a huge area. Okay, so that's why research in this field is always oriented towards minimizing the band gap by modifying a material so that area requirement should be less for getting a same output. So with this, I think so I have explained you enough. Still you have any doubt, you can write down, and before the class ends, we can discuss this thing. Okay. So efficiency of solar cell, I have explained, it's electrical power output by power intercepted, basically. Okay. So you know these things very well. I'm not going to detail this, but you can go through. There are basically, when you talk about the classifications, okay, there are three major cell types. Okay, as per the manufacturers, as per the available data. Okay, there are crystalline silicon PPV modules, photovoltaic module. So this crystalline silicon, this CSI is a crystalline form of a silicon. So two types of crystalline silicon are there. Okay, single crystalline and polycrystalline. Single crystalline, monocrystalline, or polycrystalline. Okay, so this particular crystalline silicon molecule, they have a conversion efficiency of about only 10 to 12%. See what I was talking about. Okay. Then amorphous type. So you have two particular structures when you talk about this amorphous or silicon. Okay, amorphous on crystalline structures. So first thing we have discussed crystalline, that's monocrystalline, polycrystalline. Then amorphous. Amorphous silicon is a non-crystalline form of silicon. Okay, so no doubt it is not as costly as crystalline, but it is having a less cost, but there the conversion is very less, 6% only. Okay, then we have a hybrid. Hybrid means you can have a combination of crystalline as well as amorphous silicon. So they have a excellent sensitivity towards the lower light also, indirect light also, because normally these panels, they are not efficient towards indirect light or diffuse light or low light. When you talk about the hybrid system, it is no doubt works well in the low light areas also and indirect light area also. So they have a good conversion efficiency of 17%. See, in all the cases, I have not discussed, or we have not discussed that the conversion efficiency is crossing 20%. And that's a major drawback when you're talking about the solar photovoltaic cells. So this is something I'm talking about, if you see this. So you have a cell made of silicon, either crystalline, amorphous, or hybrid, and when you combine all the cells, you will form a module. When all the modules are being combined, this is called a panel. When you have a multiple panels are being installed, this is called array. Okay. So these are the components of solar system. No doubt, solar cells, they produce the DC current, direct current, when we need to convert to AC, alternating current, by using a battery. Because whatever you're using at a home, it is always an alternating current. And if you have a solar cells at your rooftop, it is producing a DC direct current. Then you must have an inverter installed over there, battery installed over there. Inverter is there to get it to AC load. Sorry, not battery, inverter. Sorry, I'm very sorry. Inverter to get converted to AC. Okay. So this is as per the applications, as per the applications. When the similar devices are connected in series, voltage adds and current remains same. You know very well. I think so you might have I know studied this kind of thing in your electronics part. Okay, so it is as per the standard protocol. When you want a lower current with high voltage, then you generally have series combination. And if you need a stable voltage and high current, then you have parallel, because here current is being added up. So this all depends on application. Here we want to have this application. Okay, so this is the area required for solar panel. This is something very important, because wherever you want to calculate, wherever you want to implement these solar panels, okay, there's a question arises: what is the area requirement? So area requirement is always given as E is equal to, so area is equal to E by I into eta. What is that? E is the electrical energy requirement in a single day as per your requirements. Maybe household, it may be commercial. Okay, I is the total intensity, and no doubt it is the efficiency. Now see this here. I told you the efficiency of solar panels is not more than 20%, but it is maybe 25-30%. See this, if you divide it by 0.2, 0.30, no doubt area requirement will be very much more. So if you are working for a very efficient solar panels, which is a requirement of the day, need of the hour, so efficiency goes suppose 50%. Okay, then you divide by 50%, the area requirement is very less. So that's why the whole research in the solar panel, solar area is going on throughout the world to minimize the area by maximizing solar efficiency, conversion efficiency. So these are some success stories, beta. Okay, you can go through. And these success stories are just because for your concern. We are not going to ask any question in San regarding success stories. You have many things over there. Okay. So these are some merits of solar PV system. Okay, clean, cheap, noiseless, safe. You know very well. Okay, suitable for remote areas. Specifically, if you just have go through the map of solar power, solar PV installations, Rajasthan is the most preferred area, because here we have a desert, we have not a fertile land. See, maximum sunlight is there due to this conditions, topographic conditions, and that's why the maximum solar fields or maximum companies are going towards those kind of areas where you have a maximum harnessing of solar radiations. Okay. So nowadays, if you go outside, like outside India, I've seen that in other often countries, when they are reasonably using this technology to such a high extent, they are using the solar panels for charging their cars. They have they have car sheds, parking sheds maintained, which are made up of panels. And when they are made of panels, no doubt they have electrical vehicles. So what they are planning right now, and when you park your car over there, by default it's getting charged because of the panels are being over there. Then you have laptop chargers, you have mobile chargers. See, all these things are there with a minimal impact on the environment. So limitations हैं ये बेटा. अब limitations है, irregular है, intermittent supply है. तो मेरे से किसी ने क्वेश्चन पूछा था कि जैसे मैंने बोला था किसी को कि you can have a solar water heaters, you can use in your hostels, या घरों में पानी गर्म करने के लिए, खाना बनाने के लिए जो LPG सेव होगी, बस एक्सेट्रा. Somebody asked कि सर शाम के बाद क्या सीन है. तो मैंने उनको यही बोला था कि बेटा बात ये होती है कि हमारा इंडिया कंटेस्ट यही है, हम 12 घंटे की एडवांटेज को ना देखते हुए 2 घंटे की डिसएडवांटेज को देख के वो चीज डंप कर देते हैं. दिन के 12 घंटे की 10 घंटे की सनलाइट की प्रेफरेंस नहीं है, शाम को जो 6 घंटे नहीं आनी उसके लिए हम बैठे हैं कि करने की जरूरत ना पड़ेगा, है ना. तो ये सब चीजें हैं बेटा डिस्कशन में मैंने बताई हैं. सो दिस इज ओवरऑल डिस्कशन बेटा इन दिस केस. सो मैं वो फास्ट नहीं जा रहा क्योंकि सिलेबस मेरा बहुत आगे जा रहा है बाकी टीचर कंपैरिजन में, तो मैं धीरे धीरे कवर कर रहा हूँ. ओके, सो आई स्टॉप हियर ऑल ऑफ यू.